at some point said is going to be the notation we use. This right here means this question. All right? So this, when you see log with the little base, this is called the base 2, and then this is 8. What this is saying is 2 to what power is 8? And then what's the answer? What's the answer? What is this? 2 to what power is 8? 3. This is called a logarithm. Right? It's just a way of writing a sentence out in a mathematical notation. I'm going to give you another one. Ready? I want us to write this logarithm here. So what if I write 3 to some power is 9? I think you could look at that and tell me what the answer is, right? 3 what? 3 squared is 9, right? Okay, but can you write this as a logarithm? Instead of that, can you write this as a log? So write this as a log. It would be written how? Log. And then what's the subscript? 3. And then what number goes here? 9. See? So when you read this, what you're saying is 3 to what power is 9? And the answer would be 2. 2. 3 to what? 3 to what power is 9? 2. 3 to the second power is 9. So this over here is called the log form, and this over here is called the exponential form. I'm going to try something different now. I'm going to give you the log form, and I want you to write the exponential form. So what if I write this? New example. What if I write log base 5, 25 equals, well, I'm not going to put the equals yet, but what is this saying? 5 to what power, right? 5 to what power gives you 25? How could I write that over here? 5 to what power, right, is equal to 25? Y'all see how I'm transforming this idea into this idea? Now, do we know the answer? What is the answer? 2, right? What about this? What if I give you the log form here and I ask you to go to the exponential? Log base 4, 1. Log base 4 of 1. Who wants to volunteer? I hear from the same people, so I'm looking for somebody new. Yes, ma'am. You know what I just heard? I should mute my microphone. Is that okay? Right? So what is this saying? What is this written over here like this? 4 to what power? So I'm going to write 4 to the power of x equals 1. Y'all see that? That's what this logarithm is really saying. Hey, 4 to what power gives you 1? Do y'all know the answer? Anyone know the answer? 0. 0. 0. Why? Because 4 to the 0 is 1. Remember we said any number to the 0 is 1? Right? Okay. Are you kind of getting the idea of what a logarithm is? It's just a mathematical expression to say something that we're trying to achieve. So let me see if I can generalize this. This is where things get really weird. Let me try and do this in general. In general, if I write a to the x equals y, That's exponential form. What would that look like in log form? So log, what's the base? A, right? Because what is this saying? A to what power is y, right? A to what power is y? So over here I put the A here. What goes here? You didn't understand that? No? Okay. What goes here? Y. Y, right? And then that must equal what? The x. This is the general form. This is exponential form. That's logarithmic form. Now, we're almost out of time. I teach my students this thing that I've never seen it in like a textbook or anything like that, but maybe it's out there somewhere. I teach my students this thing called the loop, all right? The loop. And here's the way the loop works. I want to leave these up here for a reason here. A lot of students have trouble getting from this form to that form. So what I'd like you to see here is that if I start with the A and I raise it to the x and set it equal to that, then I create this equation. Do you see this loop? Take this, raise it to that x, and set it equal to the y. A raised to the x equals y. A raised to the x equals y. Look at all these problems over here. What is this saying? 5 raised to the second power, 5 squared, equals 25. Is that true? 5 squared is 25. How about this one? 3 squared is equal to 9. Is that true? 3 squared is 9. What about this one? 4 raised to the 0 should be 1, right? 4 raised to the 0 should be 1. Y'all got to give me just another minute. Okay? Any questions? All right. I'd like to ask you the value of some logs again. Find the value of log base 5 of 5. So what is the question that's asking?
What power will make 5 5?
So 5 raised to what power gives you 5? 1. Right? 5 to the first power gives you 1. Yeah, sorry. 5 to the first power gives you 5. What if I change it and do log base 7 of 7? What's that? 1. What's log base 3 of 3? 1. Yes? What's log base A of A? So A raised to what power gives you A? It's the same as these, right? Shouldn't it be 1 all the time? Yeah? I'm almost there. I'm almost there. I need 2 more minutes. Yeah, and I have a minute and a half. So this is important. And then the next one is the real important one. This is the real important one. So see if you can follow this. What if I had log base 5 of 5 squared? Let's see if you can figure that out. What's the question that's asking? 5 to what power is 5 to the second power? 5 to what power is 5 to the second power? 2. It's almost so obvious it's hard. 5 to what power is 5 squared? Well, 5 squared, right? 5 to the second power is 5 to the second power. What if I change it and I do log base 7 of 7 to the third power? This is saying 7 to what power is 7 to the third power? 3. What if I say log base 9 of 9 to the fourth? So 9 to what power is 9 to the fourth power? 4. what would be a general statement? What would be a general? I circled this one. This was pretty general. If I say log base A, right, of A to like something, right? Let's say X. Then what would this be? X. A to what power is A to the X power? Well, X. A to the X is A to the X. This right here is going to be super important to us next class because, believe it or not, this is the exponential function we've been dealing with, right? That's our exponential. And then this right here is a log function. And so what happens is if you put an exponential function together with the log function, they kill each other off and you get back what you started with, which means like we plug in X, this happens, then that happens, and it comes out X. So it's like X went in, something happened, then it went through again, and something happened, came out unchanged. And that's what inverse functions do. So we're going to have a way of undoing an exponential, and it's going to require a logarithm. And if we do that, then we will be able to solve that equation that we stopped where the r was trapped upstairs. We're going to be able to get it down. All right, homework-wise, let me send you a homework where I ask you to do some conversions. Exponential to log, log back to exponential. I'll send that out later today or tomorrow, okay? Otherwise, have a great weekend. Yes.
Can you remind me about the test, the switching the floor thing?
Switching the what?
Replacing the lowest suggestion.
Oh, yeah, it's too late now. I'll do it another time.
Just remembered.
Yeah, no, it's okay. We have time. We have time to talk about that. You as well.